This video is going to show you how to write a quadratic equation in standard form if you are given a graph or if you are given a table. We're going to start with the graph. The first thing I want to do is I want to look at my graph and I want to find where my x-intercepts are. So I look at where the graph crosses the x-axis and I see that I have one x-intercept here at 2, 0 and another one here at -3, 0. I am going to use my x-intercepts to help me write the equation in factored form, and then once I have it in factored form, I can multiply it out using my area model to write it into standard form. So my x-intercepts are -3 and 2. When I have my equation written in factored form, I have two sets of parentheses. Each set of parentheses can help me find what my x-intercepts are when I have it in factored form. So if I need to write it in factored form, I can use my x-intercepts to help me write it. I know that whatever I have inside this parenthesis, I want to make it so that if I were to plug -3 in for x, I would end up with 0. So if I plug -3 in here for x, I would have to then add 3 to make it 0. So the expression that goes inside the parenthesis is going to be x plus the opposite of whatever my x-intercept is. So since I had -3 here, I would have +3 here. Since I have +2 here, I'm going to do x minus 2. Now remember, since these are the x-intercepts, if I plug them into my factored form, I should get 0 for each parenthesis. Now I have my equation in factored form. I'm going to use an area model to help write it into standard form. So I make my area model. X plus 3 I'm going to do on this side, and x minus 2 I'm going to do on this side. So now I fill in the inside. X times x gives me x squared. 3 times x gives me 3x. X times -2 gives me -2x. And 3 times -2 gives me -6. So now I can rewrite my equation in standard form, and it would be y equals x squared. 3x minus 2x is going to give me a positive 1x, so plus x minus 6. Now I need to make sure that I didn't have to multiply my equation by some number, the a value out in front. And the way I check is by looking at my y-intercept. My y-intercept is what I get when x is 0. So if I were to plug 0 into my standard equation, I should get the same thing that I get on my graph here for my y-intercept. So if I plug 0 in here, I would get 0 squared plus 0 minus 6. So that does indeed give me a y-intercept of -6, and since that's what it was on my graph, I know that I wrote my equation correctly. So then my final answer, the standard form of my equation, is y equals x squared plus x minus 6. Now I'm going to do the exact same process if I have a table instead of a graph. It's just that I'm looking for my x-intercepts and my y-intercept in my table rather than on the graph. So my x-intercepts are the points where y is 0. So I look to my table and I see that here is a point where y is 0 and here is a point where y is 0. So again, I'm going to start by writing out the factored form. So I'm going to have my two parentheses, and I always want to do x plus the opposite of what my x-intercept is. So since my intercept is 3, I'm going to do -3, because if I were to plug 3 in here for x, I would get 3 minus 3, which is 0. Then I do the same thing for this x-intercept, x minus 5, because if I were to plug 5 in here for x, I would get 5 minus 5, which is 0. That's my factored form. Now I'm going to do my area model so that I can double check that I don't need an a value. My area model here, I have x minus 3, x minus 5, and then I'm going to multiply. X times x gives me x squared, -3 times x is -3x, x times -5 is -5x, -3 times -5 is a positive 15. So now I write my equation out, and I've got y equals x squared minus 8x plus 15. And looking at that, I see that my y-intercept, if I plug 0 in, I get 15, and I look at my table, my y-intercept is the point where x is 0, and it is 15, so I know I wrote my equation correctly. I don't need to worry about an a value, and there it is.